Welcome. In this video, we're going to work through problem number 11 from the first day of quadratic application problems. The way it's going to work is we're going to kind of go through it step by step. I'm going to give you a hint and then ask you to pause the video and work through that hint. If at any point along the way you feel totally good to go, ignore the rest of the video and then go on and complete the problem independently. All right, let's start with hint number 1. The first hint is read carefully the problem and highlight or pull out or underline or do something that makes you really aware of what the key information is. All right, do that and then come back and we'll do it together. I'm going to read the problem and just highlight key things I see. All right, a rectangular tract. Okay, I really see rectangle. It's a tract of land. That must just be how they describe the land. It's 20 by 16 meters, has another rectangle in it that's a swimming pool, and it's built in the middle. All right, so I know that it's got to be symmetric right in the middle of that rectangle of land. The pool is to occupy 60% of the area of the land or the tract, and the edges of the pool are all the same distance from the edge. Okay, so it's right in the middle. What are the dimensions of the pool? All right, so that's really helped me think through what's key information I have and what this situation is. That was hint number 1. So hopefully you had something similar. For the second hint now, what I want you to do is pause me and draw a diagram and label the diagram with as much information and numbers or dimensions that you have. All right, pause that and come back and see my diagram. Here's my diagram. Did you get something similar? Now, one thing I noticed, I remember, is these are all those equal distances because the pool is right in the middle of the land. I don't yet have a way to describe the dimensions of my pool, and that's really what I want to find. So there's a key piece of missing information here, and that is what is the width between the pool and the edge of the land. And I'm going to define a variable for that. I'm not going to be very creative, and I'm going to just let x equal, and let's just maybe call this something like the width of the strip of land. So width of strip, something like that. And I know this is in meters. All right, now that we've defined this variable, pause me and add that variable and any other additional information you can to your diagram. I've added a few more pieces to my diagram. First, I know all of these widths. This is sort of what I'm thinking of as a strip of land. Those are all the same. They're X. So now I have enough information to figure out the dimensions of the pool. And it's the total dimension, 20, minus this strip X, minus that strip X. So 20 minus 2X. Same for the other dimension. It's the entire width there, 16, minus this strip of land, minus that strip of land. So 16 minus 2x. All right, so here now is hint 4. Hint 4 is we now have enough information to write an equation about the situation. We need to find the dimensions of the pool. And one thing we know about that relationship is that the area of the pool, and I'm going to come back to this piece, is equal to 60% of the total area. There's hint 4. Pause me and use this information to write an equation for this situation that follows that overall strategy. Here's the equation I got. The area of the pool itself, length times width, length times width. It's equal to 60%. 60% is a decimal, is 0.6, 6/10. And that's times the total area, length times width, length times width. Hint 5, solve the equation. When you solve the equation, you're going to find the value of x that makes this equation true, and that x is going to give you the width of the strip of land. Did you get x is equal to 2 or x is equal to 16? If not, pause me and see if you can find and fix your error. Here was my solution. A couple of things to highlight is sometimes when I'm multiplying binomials, I just find the area model so much quicker. You could have also double distributed. I also noticed when I got here that all of the terms are divisible by 4, had a GCF of 4, so I divided both sides by 4 just to simplify my life. Mathematicians love to make problems simpler as possible. I then set the quadratic equal to 0, and I love this because I have two options. I first just spend about 10 to 15 seconds to see if I can factor it. I could in this case. If not, just use the quadratic formula instead. Um, let's look at these solutions. Are both viable? Do both work? X equals 2. Could the width of the strip of land be 2? Absolutely. Could it be 16? Well, no, because the dimension here is 16 for the land, so it's no way these can also both be 16. So we can go ahead and rule out this dimension, and we know the strip of land around the pool is equal to 2 meters. Sometimes when I find that, I go ahead and add it to the diagram just to help out. All right, the last step now, and the last hint is how can you use this information that we just found, the strip is equal to 2 meters, to actually answer the question asked. Pause me, do that, and then come back. The pool's dimensions are 16 meters by 12 meters. I knew the pool was 20 by 2x by 16 minus 2x, substitute in my value for x, and get to the dimensions. All right, I hope this video helped you think through this problem. Please go and keep working on problems. You might want to try an EB level problem or go back and try one of the other two PB problems if you were stuck.